In this lesson, we're going to get into bounds a little bit more in Scala. And I talked about bounds a little bit in the Introduction to Types lesson. And now in this lesson, I just want to go a little bit further into that. So in that lesson, I showed a specific example of something like this. And this is more of a generic example. I hate to overload the word generic, but here I'm saying that anytime you create a function and you want to make sure that the parameter you're taking in right here is of some particular type of type, the way you do that is you say A followed by this symbol right here, and then you have that required base type. And then the way you read this, again, is that the parameter A has the generic type A, and then when you come back over here, it says that A must be a subtype of whatever the required base type is right there. And now if I scoot things around just a little bit so I can see everything, I'll put that up over here. Have the compiler running over here, and we mostly just need to see that output. And then we can start working here. So this is an example I wrote for Scala 2 back in the day. And let's go ahead and start updating that for Scala 3. So this is similar to the previous example that I did, but it's going to be a little bit different too. So we'll start off with that trait. And this line of code here says that name is going to be a member of sentient being. And the only thing we're saying about it right now is that it's abstract and it has this type string right there. And then instead of watching me type, I'm going to just bring this over here like that. And to look at that, this says that a first trait is going to be animal with legs extends sentient being. And then a two-legged animal extends animal with legs, and a four-legged animal extends animal with legs. So that's what I have so far, and then I'll come over and copy this code as well. And now what I'm doing here is I'm saying, well, we're going to have a class named dog, and that's going to extend four-legged animal. Then I'll have a class named person. It's going to extend two-legged animal, and then I'll have a snake, and it's going to go back to the top and extend sentient being. So it's not going to extend anything here. It's just going to go up to the top right there. And if it helps to see that visually, I put this UML diagram up here. So again, this trait, sentient being, is up here. We have animal with legs. Oops, I actually did this diagram a little bit differently. So let me create that. And what I call that? So this is animal without legs. Extends sentient being. And then I could say, well, we'll do that. And then snake does that. So save that. And now I believe I have what the diagram is showing. So I have sentient being up here, animal with legs right there, two-legged animal extends that, four-legged animal extends that right there and there. Then I have animal without legs extends sentient being right there. Snake extends that one right down here. And then we have dog is a four-legged animal and person is the two-legged animal. So this is the visual representation of the code right here so far. And now what I do over here is I create a function named getName. So let's scroll down a bit, and we want to create that function, so it's called getName. It's going to take a generic type A. I'll just do that part for now. And then A:(A) is what I'm doing there. So again, this is the input parameter, and this refers to the type. And it's going to return a string. So we say string equals that, and then A.name. And you'll see right away that that fails. And this is the compiler's way, without looking at the error message, I guess, let me go ahead and save that and you'll see the error message. And this is saying value name is not a member of A. And that's because the compiler is looking at this and saying, well, I have no way of being sure, I have no way of being guaranteed that A right here has a name method. And the way we do that is we come over here and say, well, A is always going to be a subtype of sentient being. And when I press save, now you see the error messages go away. So again, this particular syntax right here is a way of telling the compiler that this generic type A is going to be a subtype of sentient being. And therefore, because it's a subtype of sentient being, we can look at the code and say, oh, okay, yeah, it's going to have a name member right here. So it's perfectly safe to call A.name right there. And then what I do in this code right here is several examples of that. And what I'm going to do here is put some print lines around those. Bear with me just a moment. And I'll save that. And when I save this code right here, you saw the output right here. Let me do that again. And this shows that getName works with person, dog, and snake. And that's all because we're saying that the generic type A must be a type of sentient being right here. But now if we were to come down from the hierarchy and say, instead of extending sentient being, I only want to deal with animals with legs, then I could delete that right there and replace it with animal with legs right there. And even before I press save, you see the error message right there. And it's saying snake noodles is not going to work. And when we look at the error message over here, you can see, well, I found bounds.snake. So bounds is the name of our package right here. So it's saying I found bounds.snake, but what I'm requiring is animal with legs, and that's because I'm requiring that right there. So I just made that change to show how this error works. So earlier it was working when this was sentient being, but then when I started coming down this type hierarchy to here, only these types will work now, and then these types will not work. And that's because getName now requires a subtype of animal with legs. And since I created this example over here with Scala 2, a good point to note is that the new error message is much, much nicer than the old error message. The old error message had this inferred type argument snake do not conform to the method getName's type parameter, bounds, and then it showed these symbols right there. And as I mentioned, the new error message is quite a bit easier to read if you happen to know already that the package name was bounds. It's just saying that I'm requiring animal with legs and I found a snake. So this is a much, much nicer error message than what we had in Scala 2. And then the other thing to say is that this symbol right here creates what's called an upper bound. So bounds are what we're working with, and this is a way, again, of saying that A must be a subtype of animal with legs. And then more generally, I show here, A must be a subtype of B. You can also have lower bounds, and in that case, this symbol right here would be reversed, but that's not very commonly used, so I'm not going to show that at this time. And now the next thing I like to do is show a little more complicated example. This one also comes from the Scala cookbook. I believe it was the first edition of the cookbook, and you'll probably see that here as we look at some of the code. So the problem statement there is that you want to specify a class or method that takes a type parameter, and that parameter needs to be limited so that you only take in a base type or a subtype of that base type. And as I mentioned, this means we're going to be working with an upper bound. So to demonstrate this, let's go ahead and copy this code right here and put that into here. So hopefully you're familiar with Star Trek. So we have a trait of a crew member, then we have an officer extends a crew member, and a red shirt extends a crew member. And recall that in the history of Star Trek, many of the red shirts died. Then we have these other traits of captain, first officer, ship's doctor, and Starfleet trained here. Then let's see, what do I do next? So then we create Kirk and Spock and Bones right there. So in this code, I create Kirk, or Captain Kirk. He's an officer with a captain. Spock is an officer with first officer. And Bones is a new officer with the ship's doctor trait. Let me move this over some more so we can see all these things here. And now if you could imagine that given the setup of these types right here, you want to create some type named crew, and you want to be able to create a collection of officers like this. So I will copy that. And this is going to go here, like that, and then get rid of that. And I haven't defined crew yet, so that's why that's red right there. But in general, this is the type of code I want. I want to be able to create a crew of this type of officer. And I want to allow these three to be in that crew. But if I was to try to add a red shirt to officers, like I show right here, so that would be something like, well, val red shirt equals new red shirt. Like that. And then if I tried to do officers plus equal red shirt, this is the type of code right here that I want to disallow. I don't want this to compile. So we could say, don't want this to compile. So this is the kind of thing we can enforce with a nice type system like Scala has. And to do this over here, I do a totally different approach than anything I've shown so far. And that is, I create a class crew. And in this case, I do want to accept generic types, but I only want crew to ever be instantiated with crew members. And that's the way we define this first part there is I say, whatever goes into the crew type right here, it can only ever be crew members. And then what I'm going to do is extend array buffer and make sure I parameterize that like that. So even though the syntax is a little different, it's actually very, very similar to what I did before. So I'm just saying I want this type parameter right there, and I'm saying it can only accept crew members. And then this a parameter here is this a parameter right there. So now crew will behave just like an array buffer, but it will only allow crew members. And now since I already have this code down here, you could see that it's not compiling, which you don't want it to compile right here. That's exactly what you want. So if I comment that out and save that, now we don't see any error messages down here, and we don't see any error messages here, so we can see that that's working. And as I mentioned, if I take the comments away right here, this code won't compile, and that's exactly what we want, because we want this instance right here to only contain officers. So in this example, I use this code right here in combination with this code right here to create exactly what I want with a Scala type system. And again, that's to create a crew of officers only. And when you try to add anyone else to that, it's going to fail. It won't even compile. So I hope this is a pretty good example of how to use the Scala type system for something like this. And then in the Scala cookbook, as I go along in the discussion section here, you can see that I started adding just a little bit of additional complexity to this example. So now class crew currently says A should be a subtype of crew member, but you could also say it should be a subtype of crew member with Starfleet trained. That's a little bit more precise. And right away, you see this error message right here, and it's like, now officer does not meet that definition. And now since the type parameter A must always be a subtype of crew member with Starfleet trained, and that's essentially the same as saying crew member and Starfleet trained, the generic type A here must extend or be subtypes of both crew member and Starfleet trained. So because of that, we also have to come over here and say, well, this one also has to be officer with Starfleet trained. And that's because this previous code here would not compile because I only had officer there like that. And that is not a subtype of crew member with Starfleet trained. So again, you have to add that back in there like that. And that will get this line to compile. And now you see that the blue line compiles, but these other lines here won't compile. And that's because Kirk, Spock, and Bones are only officers with captain. They don't have Starfleet trained as well. So the way I resolve that in the book is like that. And we give that like that and that. So now it looks like this code here is compiling just fine, and we still don't want Redshirt to work, and you can see that that's failing as desired. So even if I came up here and I said, well, that is with Starfleet trained as well, and you'll still see that this fails because Redshirt is a crew member, but in this particular case of this crew instance right here, it's not a subtype of officer. And that's exactly what we want, at least for this example. So I'll comment out that code so that works just fine. Now, so far I've actually been typing Scala 2 code, and you can see that it works just fine with Scala 3. But another way to do this in Scala 3 is with intersection type. So you could replace that with keyword with the intersection symbol there and that one there, and save that, make sure everything is still good. Also, I didn't notice the new keyword. We can get rid of that as well and save that. And then as I scroll down in this section over here, I note that this approach continues to work as long as our instances like Kirk and Spock and Bones have these types somewhere in their lineage or their class hierarchy. So what we could do, instead of doing this code over here where I have new officer with captain with Starfleet trained, is create a new trait, and that one is called Starfleet officer. And of course, that is going to extend officer with Starfleet trained like that. And now it's just one example. I could get rid of that and say, well, this is a new Starfleet officer with the captain. And when you look down here, you see that that code still compiles, so you can use this approach or this other longer approach here. And I'm only doing this code over here to show the flexibility. And specifically, the crew will only accept types that are both officer and Starfleet trained. So no matter how you define that, whether you define it like this one here or these other two right here, as long as they extend officer and Starfleet trained, they can be added to this particular crew instance right here. And then over here, I show a few more examples of things that you can do with types. So that one is called beam down. So I could say anyone who is a crew member is allowed to beam down. So that is crew member. And I showed that as crew member, but that really should be crew members because it's taking in a crew. And recall that a crew is really an array buffer. And then I'm just printing, so I'll give that the return type of unit. And then here we could say crew members for each. And now I am saying call beam down on each member. So this one here could be called crew member, member singular. And then what I'm doing is essentially that, beam down like that. And I don't believe I defined that beam down method, did I? I did not. So this is assuming that there is some type of beam down member up here. So beam down is going to have the unit type right there. And actually, let me just give that a body so we can see some output here and then say beaming down, something like that. And this code is wrong. Sorry about that. This is supposed to be something like that. We can do crew member like that. That is the long version. Of course, the short version in Scala is that we would type something like that. And one thing I did was I just changed that to beam all down. And that's so the name is more meaningful because this is taking in a crew right here. So this function is going to beam all of the members down. And it's going to do that by calling beam down on each crew member. And the problem I have with this red squiggly line right there is I'm trying to define A to be a type that extends crew member. But if you look up here, right there, you can see that A must always extend crew member and Starfleet trained. So that's what crew must always extend crew member and Starfleet trained. And the problem I have in this function is that I'm saying I only want to extend crew member, and that does not match that type right there. So there are a couple of things that you could do if you're working on this, and you could say, well, a crew member is always going to be Starfleet trained. If you think that's true, then you could say, well, extends Starfleet trained here, and you see that gets rid of that error message and everything works. If you don't think that's always going to be true, another thing you can do is add that type here as well. And that also gets rid of that error message. So if you're looking over here and then looking over here and wondering why this isn't working, a big difference I made over here is that I actually implemented this code right here, and I don't think I did that over here. So that's why we were getting error messages here and why this code wouldn't compile directly as it was. And finally, I can implement this function as well here. So this was called get ready for the day. And here I was trying to say that, well, all of these that are red shirts can get ready for the day. So this again should be plural because crew is a plural. Crew again is an array buffer. If I look at this code right here, crew extends array buffer, so it has all the properties and attributes of an array buffer. So an array buffer is a container, so this should be plural. Therefore, this should be red shirts and not just red shirt like I showed there. And then crew of A. And then in here I could say red shirts dot for each. And what I show there is put on the shirt. And as you can see, one problem I'm going to have is that there is no put on shirt method. So we can come up to red shirt and define that. So we do that. And then I'll say unit equals something like that. So putting on the shirt. And I need to put that colon there. And come back here. I'm sorry, that code is failing because of that. And now you can see that this code is working. And again, it's working because red shirt extends both crew member with Starfleet trained up here, and because I just added this new method to it. So now this example over here is working just fine. So in summary, what I did in this portion of this lesson was to create this type hierarchy here and then create a few specific instances of officers here. And I showed different ways to create those officers as we went along. Then I showed how to create this crew and very specifically how to create it as something that extends an array buffer. And I use this generic type. So crew has this generic type parameter A, and I pass it over to array buffer. So it is parameterized when I create it. And then I put these limitations or specifications on this type. And I said that A must be a subtype of both crew member and Starfleet trained. And then I went on through the rest of these examples and I showed how to implement that with different types, like with this one right here. And then here as redshirt, because redshirt already extends crew member with Starfleet trained up there. So if you're interested in this example, come check out this page and you can experiment with the code as desired.